In this video, we're going to look at the California sardine industry collapse, and we're going to look at some data that shows the periodic ups and downs of the sardines, and we're going to analyze that data real quick. So let's get started. This is what the assignment looks like in your weekly work. So what we're going to do is we're going to read this caption here, and then we're going to look at this picture here, but we're going to look at it in color so you can actually see the different parts. And then from there you should be able to answer these questions pretty quickly. I will also be giving information that explains this question here, so when we get to that you may want to write some notes down. This is the PowerPoint for analyzing Pacific Basin sardine data, and this is the information video. So let's look at this chart that's on your weekly assignment. This is the color version, and what we can see is this is the California sardine catch. It is in blue, so make sure you're looking at yours as I show you this. So the blue one is this here. The California sardine catch went way up between 1925 and 1945, and it started decreasing roughly around 1944 or so. All right, so that's California, and it goes up, down, down, and then it stays down all the way up until around 1996. So then it starts coming up slightly, but it was depressed the whole time. Okay, the Japanese sardine catch is here, and you can see it goes up, and then it comes down, parallels California, then it goes along, and then it goes up again, and then goes down. So this is during a time when California is not catching anything, but the Japanese sardine industry is catching a bunch. And then we have the Peru-Chilean sardine catch, and it starts in the middle of 1965, and it goes up and then down. Right, so those are the three different things that are on your graph. The California, Japan, and Peru. And again, California is this one here, Japan, and then Peru here. And we'll need those later. Okay, so reading this, historical catches in the sardine fisheries of Japan, California, Peru, Chile have exhibited parallel patterns, possibly in response to global scale changes in climate. So maybe climate is driving this, and that's one of the things we're going to kind of tease out. So in the numbers of pounds of fish that are caught, over here we have California sardine catch, and over here we have Japan and Peru. So the California sardine catch is in thousands of metric tons, right? And the Japan and Peruvian is in millions of metric tons. So the amount that they're catching is way more than us. So here, this would be 3 million metric tons for the Japanese, where ours is 700,000 metric tons. So they are catching way more than we were catching off our coast. And part of that is they are in a different part of the world. We're on the eastern side of the Pacific Ocean, and they are on the western side. So they are totally different environmental conditions there. Now is a good time to stop this video or pause it and go and record or answer these questions here 1 through 5. This is the countries that catch sardines. What is the largest catch? What is the largest catch? What is the largest catch? Or actually 1 through 4. Then turn the video back on and we'll go over questions 5 and 6 with information that will be needed. So now I'm going to go ahead and read this long blurb that was underneath your graph just so that you can get all of this in. So most of the largest fisheries in the world's oceans are based on small pelagic fish such as anchovy and sardine. This graph only is looking at sardine. These species dominate the ocean in highly productive upwelling regions along the eastern edge of the oceans off of California, Peru, Canary Islands, and South Africa. So the eastern edge, sometimes it confuses, so that's basically the west coast of California. It's the east part of the Pacific Ocean, right, which is where Peru and the Canary Islands are. And they also occur in other nutrient-enriched areas such as Japan and Argentina. They appear to be inherently unstable populations that expand rapidly in numbers and area when feeding and spawning conditions are favorable, but collapse even more rapidly when ocean conditions change. So these populations are typified by having massive blooms, expansions, and then they collapse, and then they have blooms again. Within the last century, conditions did not stay favorable for the sardine population for periods of more than 30 years. When the sardine population collapsed in the 1960s, the U.S. banned sardine fishing until the mid-1990s. So from here to here, sardine fishing was banned until the middle 1990s. That's why it's flat. It was banned in the United States, so we could not catch any. The graph shows population trends before and after this ban in the amount of fish caught by California fisheries, Japan fisheries, and Peru Chilean fisheries. So questions 5 and 6. Conditions that affect sardine populations. So one of the big things that affects sardine populations is where it gets its food. So this is the marine food web. And we are looking at for 2 factors that may have led to the apparent collapse of the sardine population in 1995. So we got to look at the food web. So sardines get their food from phytoplankton, which then feeds zooplankton. Phytoplankton are microscopic plants that live in the ocean, and they are the basis of the food web, and zooplankton eat them. And sardines eat the zooplankton. So what affects the phytoplankton? Conditions that affect phytoplankton are water temperature. So it looks like, and you can see this, when we have temperature anomalies off the coast of California, warmer temperatures, there's also an increase in population of sardines, and that happened between 1910 and 1960. We had a temperature anomaly, and the sardine population went up. And we had another one around 1980, and again the sardine population responded. So temperature. Temperature also can link or affect nutrients. So when there are nutrients, there's going to be more things for the phytoplankton to draw in so that they can grow more. And if there's more things for them to draw in so they can grow more, then there's going to be more zooplankton. So we have nutrients, water temperature, and we have winds and currents. So the winds actually affect the nutrients. So when we have winds off our coast, they blow ocean water away from the coastline, and when that blows away, it allows for nutrient-rich water to come up off the bottom, and that supplies nutrients, which then the phytoplankton can use, which then feeds the zooplankton, which then increases the sardine population. So these things are all linked, and they do affect the population of sardines off our coast. So now we're going to look at question 6 also. What actions would you recommend for the fishing industries of the world at this point in time, and why? So before we look at that, we need to kind of look at what's going on with the sardine and anchovy population. Turns out that when the anchovy population is high, the sardine population is low. Right, so after the collapse in 1960 of the sardine population, the anchovy population started to go up. And then when it started to go down, the sardine population went up. And that has a little bit to do with the oxygen marine zone. Okay, so if we look at here, the anchovy population was high when there was a low oxygen marine zone, and it was farther away from the coast. So here's the coastline right here. And when the oxygen marine zone is farther from the coast, there tends to be more anchovies. And that's partly because anchovies like large plankton. All right, so the conditions for large plankton are good when there's a smaller oxygen marine zone, this area here, and when that's located a little bit farther from the coast. When there's a larger oxygen marine zone, all right, then and it's deeper, then there's a better conditions for small plankton, right? And so there's more small plankton, the sardine population goes up, all right, and then when that small plankton goes down because the oxygen marine zone decreases, right, and gets pushed farther from the coast, and the anchovies come back again because the sardines have gone down. Now this all probably has to do with, again, who's eating what. So if there's smaller phytoplankton or smaller plankton, the sardines are able to eat that better, and so their population, of course, increases. And then when there's less of that, then that niche goes away and the anchovies come up because the sardines are not there. So that kind of mirrors what we're seeing over here. The sardine population going up and then down. All right, and when it goes down, the anchovy population is going up, and that's between 1960 and 1970, which is here, and then the sardine population goes up again and down, then the anchovy population goes up. So what actions would you recommend for fishing? Well, let's think about the marine food web again. So the sardine anchovy populations are high when these populations, or when these nutrients are around. The nutrients feed the phytoplankton, which then feed the zooplankton. When they're high, if they are fished too much, then there are not going to be enough of them around, so that when the conditions get wrong, or the conditions go down, their populations decrease, and they'll even decrease more because there's less of them. Right? So there has to be some kind of mechanism so that these populations don't get too low, so when the conditions come right, that the populations can go up again. All right, well, good luck with that. If you have any additional questions, please see your science teacher.